Hi everybody, today's video is going to be about parent functions and transformations. So the first, we're going to focus on 4 today. There are more that exist, but we're just going to focus on these 4. So the first is quadratic. So that's in the form y equals x squared. Cubic, that's in the form y equals x to the third. Square root would be y equals the square root of x. And absolute value is absolute value of x. So all this means is that each quadratic function has the same general shape, but when we use transformations, we start moving them around and flipping them upside down, stretching, shrinking, stuff like that, and we'll get into that in a minute. But all cubic functions have this general shape, square root, and absolute value is always that V shape. So we're going to talk about the transformations. There are 3 main types. The first one is a translation, which we break up into horizontal shift and vertical shift. So if we're going to start with the parent, that y equals x squared for this one, you can do this on any of the functions, but for the shift we're going to talk about quadratic. So a quadratic has the parent function of that parabola, that u. And what if I want to shift it to the right 4? Well, this graph starts at 0, 0. So I need to move it to the right 4. So if it started at 0, 0, I'm going to go 1, 2, 3, 4, and it's going to start here. And that's the only thing I'm changing, so it's going to look the exact same, except for I literally just moved it to the right 4. So it's important to understand what that means graphically, but also what it means to this equation. So what happens is that I've got y equals. Now when I move to the right, that's in the x direction. So everything that happens to x needs to be with x, basically. So I'm going to write x minus 4 squared. And I wrote minus even though I'm going to the right because it's always going to be opposite. Okay, and I know it can be a lot of information right now, so make sure you just rewind and rewatch, pause whenever you need to. So that's the horizontal shift. I'm going to change x, right, because I went to the right in the x direction, and it's always going to be opposite here. So a vertical shift, well, let's continue to use y equals x squared. So my parent function is that parabola. And I'm going to move it, let's say, up 3. So we're going to take that 0, 0 and move up 3 units. And then we have a new parabola. So it affects the equation differently. It's not changing x, right? Up means y direction, excuse me. So I'm not going to change x, but instead I actually call it the outside of the function. So it's x squared, but on the outside I need that plus 3. Okay, so that's the difference. If you have a horizontal shift, it's going to go on the inside here. If it's a vertical shift, meaning it's changing in the y direction, it's on the outside because it's changing y. So visually, I think it's easy to see what happens with a horizontal shift and a vertical shift, and we'll get more into the equations in just a couple minutes. So then we have dilation. So that means expansion or compression. So for this one, I'm going to use the absolute value of x as my parent function. So that also starts at 0, 0, but it makes a v. So let's say it's going to expand by 3 in the x direction. So what that means is it's going to expand, so it's going to get wider. And we could use our calculator. As we move on, we're going to get more exact on actual points, but visually you can see it expanding. So the equation, here's where things get tricky. We're in the x direction, so it has to be next to x. We're going by a factor of 3. So in the equation, I need to put 1/3 x. Okay, it's going to be the reciprocal. And you may notice a pattern. It was opposite with the shift, and it's reciprocal with the expansion on x, only in the x direction. Because in the y direction, if again I choose the absolute value of x as the parent function, and I this time I'm going to go compression, right? Compression by 4 in the y direction. I'm going to compress it so it really is getting skinnier. Compressing, right? Getting smaller. And visually, that's what happens. But when I go to the equation, I'm not changing x this time, right? I'm changing y. So this 4 is going to go on the outside. And it stays the same with y, just like it did in the shift. And the last one is a reflection. Okay, so the reflection, in this time, let's use y equals the square root of x as our parent function, which has that shape. And if I'm going to go over the x direction, or the x-axis, I'm going to reflect over the x-axis. That means my points up here are going to reflect over the x-axis. So my new graph is the same, except it's just upside down. Right, I'm just plopping it over from top to bottom over that x-axis. So where we need to be careful is we need to really think about what is happening. When you reflect over the x-axis, y's are changing. So the y value is changing, right? Because it's moving up and down. So what that means is it's affecting y. Even though it's going over the x-axis, the y values are changing because it's going up and down. So when I write this equation, it's going to be y equals negative square root x, because y is changing when you go over the x-axis. So we're going to try over the y-axis this time. Y equals the square root of x. So again, just that same parent function, just a sketch. When we talk about over the y-axis, x is changing. Because the y-axis is up and down, and if I'm going to flip over the y-axis, I'm going from left to right. So it would face this way over the y-axis. And you can see that since it's going from left to right, x is changing. So in my equation, I need to change x. Okay, so I know that was a lot of information. If you need to rewind and rewatch, please do so. We're going to talk more about this on the next page to give you a better idea of what's going on. So example 1, we're going to describe the transformations given that the parent function is y equals f of x. So again, f of x is just a function. And I want you to remember two things. I remember that x is with x and y is with f of x. Right? Because x is obviously x, and remember, f of x is just a fancy way of saying y. It's just function notation. So this is what you really need to remember. Because here, I'm saying, look, I'm doing x minus 3. So that means it's going to be with x. So that's horizontal. And anytime I'm adding or subtracting inside, if we go back to the other page, that's what we did here with this horizontal shift, okay? When I'm adding or subtracting. So that means we're going horizontal, shift, and we're going right 3. Because the other thing you need to remember is that x is always reverse, right? It's like if you look back on our other page, everything when we did in the x direction, we had opposite and we had the reciprocal. So it's always reverse of what you think. So again, this x minus 3 here, since I'm subtracting with x, is a horizontal shift to the right. And then I have this minus 1. Not on the inside, it's on the outside. We're doing this f of x here, x minus 3 technically, minus 1. So again, it's subtraction, so that's a vertical shift down 1, because that's in the y direction. It's the same. Okay, so now I have a negative f of x. See, that means, remember, f of x is y, so that means opposite y. So y is changing. In order for y to change, it needs to go up and down. So it has to go over the x-axis. So I'm going to say that is a reflection over the x-axis. And if you want, you could look back over here when we did reflections. When we had that negative on the outside, it was a reflection over the x-axis. So that's another way to tell what the transformation is. Then I have this plus 1 that's on the outside, so it's y, so that plus or minus is always a vertical or horizontal shift. So since it's f of x plus 1, it's vertical shift up 1. And then the last thing I have is this negative x on the inside. So x is changing, reflecting, moving. So if x is going from one side to the other, it has to pass over the y-axis. So this is a reflection over the y-axis. And we knew that also because up here when we had the negative x, it was a reflection over the y-axis. So there's a couple ways to think through that. Okay, so we have 2 more examples. And the first one is example 2. Given the following transformations, write a single equation using the parent graph, y equals x squared. Okay, so we're going to fill in the blanks here. We're going to put this 2, the reflection of the y-axis, the vertical shift, all to change this y equals x squared. So horizontal expansion is changing x because it says horizontal. So if we look on the other side, horizontal expansion, we multiplied x by the reciprocal. Remember, x is always reverse. So that horizontal expansion is going to be 1/2 x squared because I have to multiply by x because it's horizontal expansion and it's always the reciprocal or reverse. So that's one big thing to remember. So then I have a reflection over the y-axis. Well, reflection over the y-axis means that x is changing. If you look at your graph saying the y-axis, to move a point from one side to the other, we're changing x here. So that means I need a negative with that x. And then lastly, I have this vertical shift down 3. So on the outside, I say minus 3. And that's how you write an equation. Okay, last type of problem. Right now we have the function f of x equals y, passes through the point -1, 5. Remember, an ordered pair is always xy. It says name the point the following functions would pass through. So if I'm going to do a vertical shift down 3, right in a 3, it's supposed to say 3 there, that means I need to take this point and go down 3. So vertical shift means y, down 3 means y minus 3. Well, the y value is 5, minus 3 is 2. I didn't change the x values because all I did was a vertical shift. So x stays the same, and now I'm going through 1, 2. You could also plot the point, -1, 5, and then shift down 3, 1, 2, 3, brings me to -1, 2. So that's really all we're doing. So here I have a horizontal shift left 2. So that means we're going x plus 2, right? Because x is always reverse. And then a reflection over the x-axis. So again, when we go over the x-axis, I'm changing y. So I'm going -y. So here, well, that means I've got -1 plus 2 is 1. And -5. So my new point is 1, -5. So I'm just doing this algebraically. Again, horizontal shift means I'm changing x plus or minus, and since it's left on x, it's opposite. So x plus 2, and then reflection over the x-axis is always the y is changing. And then lastly, I've got a vertical expansion, which is y, by a factor of 2. So it's really just 2y. So 2 times the y value, which is 5 up here from the given point, equals 10. I only went the vertical expansion, so x is the same. My new y value is 10. So, wow, I know that was a lot of information. Please make sure that you rewind, rewatch as many times as you need, and write down any questions that you have to bring to class, and we'll go over it when we see each other next. Bye.